Okay, let's talk about waves. What are the different type of waves and what can we measure about them? And no, I don't mean these kind of waves, but you know what? Sure, why not? Let's talk about those kind of waves too. All right. A wave, simply put, is something that is created when a source of energy causes a vibration. Now we have different types of waves we're going to talk about. We're going to mostly focus on the mechanical waves for now. Mechanical wave is a disturbance in the matter. Something has happened and that's going to carry energy from one place to another. Here I've got this video here of a quarry and a massive explosion, a lot of energy released. And you'll see that that energy is carried out in the form of a wave. There is a shock wave in the air and then of course the, good old regular wave right there. But that carried energy from one place to another. Ocean waves are a kind of mechanical wave, and the medium is the material through which a wave moves. In the case of an ocean wave, the medium is the water. If it's a slinky, the slinky is the medium. If it's a sound wave, probably air is the medium through which that wave is moving. So, in order for a mechanical wave to travel, it has to have some kind of medium. Electromagnetic doesn't need it, but a mechanical wave, that explosion that you saw there, has to have a medium, has to have the thing that it's traveling through. So we have three types of waves. Let's go over them. First kind is going to be the transverse wave. A transverse wave is a wave where the vibration of the medium is perpendicular to the wave direction. Here you can see the main parts of a transverse wave. The amplitude is the distance to the top from the midline or from the midline to the bottom. Top is called the crest, bottom is called the trough, and the distance between each peak or each crest is called the wavelength, which we use the symbol lambda for. So here you can see we have a transverse wave where the vibration is up and down as it moves left and right. So this is a better example, a more moving one in this case here. The wave is moving to the right and the vibration is moving up and down. This is a transverse wave. They are perpendicular. This is going to the right, this is going up and down. When they are perpendicular as opposed to parallel, when they are perpendicular, that's a transverse wave. Here's another great example that I saw. All these soldiers that are just kind of, it looks like they're dancing, but you have to think of it as the wave is traveling to the right, and the soldier itself, if you looked at the individual motion, let's just pick on this guy, for example. Let's watch this guy. All he is doing is moving up and down. The wave moved left and right, but he himself is just going up and down. When it's perpendicular movement and vibration, that's called a transverse wave. The other kind is called the longitudinal wave, or the other big kind, where essentially you have a slinky and you're sort of like pushing it forwards and backwards. You have compressions, the areas where it's really tight, and then rarefactions, where areas where it's a little more separated. A longitudinal wave is where the vibration is parallel to the wave direction, so they're going in the exact same direction. So here I have a wave. As it pushes through here, it sort of compresses stuff. So that's why it's sometimes called a compressional wave. Here you can see the wave is obviously moving to the right, but if you look at the motion of any one individual line, it's just in a vibrator wiggle back and forth. Watch right here. It moves to the right and then the left. So the wave is moving to the right, the vibration is wiggling the exact same direction. That is called a longitudinal wave. Now, our third kind of wave is called the surface wave. This is where it travels along the surface between two media. This one is kind of a combination of a transverse and a longitudinal wave, and it actually goes in circles. So if you watch the motion of any one of those individual particles there, they're for the most part, they're not going up and down or side to side. They're kind of going both. The closer they are to the surface, the more of a, more movement there is. This one down here still going in a circle, but obviously a smaller circle. Here's another example. If you were to track the motion of any one individual particle, it roughly goes in a circle. It is going both up and down and side to side at the same time. Boy, that is mesmerizing. We could watch that all day. So, quiz. What kind of wave is this? Well, you can see the wave is kind of moving to the right and the vibration is up and down. In that case, that is a transverse wave. They are perpendicular to one another. All right, so the transverse wave characteristics, which I mentioned before, crest is the high point, trough, low point. The rest position, also known as the midline, is what we're comparing it to. The amplitude is the height from the midline to the crest or from the midline to the trough. And the wavelength, remember, symbol is lambda. That is the distance from one crest to the next crest, or from one trough to the next trough. All right, I do want you to draw this in here, just an example of something. These have something that is constant, something that is changing. Well, they have constant wavelength. The distance from crest to crest is identical, but the amplitude is different. This one has less amplitude compared to that. So constant wavelength, changing amplitude. This one, on the other hand, is different. The amplitude is the same. In both cases, the height from the midline to the trough or the midline to the crest is going to be the same, but it has a changing wavelength. Draw those, label those, and be able to identify those, because that will be something on the test. All right, periodic motion. Any motion that repeats at a regular time interval, like, the pendulum of a clock swinging back and forth. Wave motion is repetitive. This means it repeats. And period is the length of time for one cycle to occur. The time between the and the, that is the period. The units for this are seconds because it's just measuring the length of time. And it is the inverse, or the kind of 1 divided by the frequency. Frequency is the number of cycles in any given time. And we measure this in a new unit, hertz. Hz, capital HZ, and the units for that are 1 per second. So if something happens once per second, like, we would say that's 1 hertz. If it happens twice per second, we would say that is 2 hertz. And here you can kind of see how they are inverse. This one down here is flashing with the highest frequency, 2 hertz, 2 times per second. But the period, the length of time between each one, is half a second. Here this one is flashing essentially at 1 hertz once per second, and it is 1 second between each beat. And this one up here has the lowest frequency, 0.5 hertz, and it is 2 seconds between there. We're going to go over how to calculate those later on. Click on this video right here if you want to jump ahead to that. Get it? The shuttle frequency is 5 hertz, 2, 3, 4. Because hertz is a car rep. Never mind.